was messing around with Affinity Photo's procedural texture filter, and I was using polar coordinates. I was trying to actually do something else, but I stumbled across this mathematical function, and I thought, well, that looks pretty cool. And so I started working with it, and I added some variables to it to change it, and then I noticed this weird pattern in the numbers, and so I'm going to talk about that. So I'm going to start out just going over this, and if you want to skip the rest of it, go right to the formula, or just grab this equation and use it to make valentines. Go right ahead. But I'm going to do the I'm going to go over the this weird thing I noticed, which had to do with some of the coefficients I put in there. And so I'll talk about the formula, and then I'm going to look at some of the numbers and a little bit of number theory, or whatever it is going on. Sort of strange. All right, so first of all, yeah, I came across this and it looks pretty cool. And then I added some factors to it so I could change it. So here's another one where it's sort of a cross between a heart and a spiral. So, and this one you can change to make it, this will bring these up a little bit or down. This one will make it start to distort it in weird ways, like that. And then, let's see, I can add a phase distortion to this. Okay, that just sweeps through the different values. And then and add this alignment factor. And this is the one that sort of introduced a weird thing to this one. So bring this back down to 0. All right, so I'm going to look at the formula or the equation for this one now. So it's I'm calling it a heart curve. There are some curves in mathematics called cardioids, so I guess it's sort of like one of those. If I dug into it a little bit, I'd probably notice it's similar to one of those. I just have two variables, vector, for the colors. So in this one, I just have two colors. And then I first set up my scaled x and y variables, and then I do my radius and my angle, theta. But at the time I was working with this, I didn't know about atan 2, which uses separate two values for, a value for y, and then a comma and a value for x. So this one, the sign gets messed up, and it causes this artifact, which is this dark line in the middle of this, I think is caused by that. But if I switch over to atan 2, I no longer get the heart shape. So this one gives me the heart shape, the other one doesn't. So I have to stick with this one. I tried different ways to get rid of that. Probably you could figure out a way to do that, but I haven't figured it out yet. Okay, and then here's the oscillator. So I have, I'm using a smooth oscillator, the S curve on the outside of this, and then this is the interior part, which is the radius plus b times sine of c times theta times sine of x plus g, and then I add another phase over here. So originally I didn't have this g and this d, and really you don't need the c or the b. I suppose you could take those out too. But I wanted to have parameters that I could vary to change the shape of this, so I put those in. But it's this g parameter that acts weird. So it's a phase offset of a sine, which is inside another sine. This one has a d offset times 180. And then, anyway, after that I smooth step it. I've got two edges, and then I'm fading between those two edges. So f is the factor for the fading between the two. Okay. So let's look at this. So I have this, and I'm just going to go back down to 4, 3, 2, 1. I'll put a 1 on that one, And if I go all the way down to 0, it's just a circle. 0, 0 is a circle. If I don't have these at anything, it looks like, if I have them both at 1, it looks like that. So you probably can't see much of a dip on there, but it's starting to become that heart shape. But if I change this one, this shifts the alignment. And if I shift this far enough, it should align with the other edge. And so where does that happen? Well, it turns out that really aligns well at 90 degrees. So a phase shift of 90, it aligns there. I could go up, and now when I shift it back down, it aligns again right at 180. Oops. Okay, so it aligns again at 180, and if I go up to the next one, guess what? It's going to move it down this time and align at, I'm just going to type it in, 270, you guessed it. And then next one, I'm just going to be 360. It's aligned again. So no surprise there. But now I'm going to change this B factor to 2. Make it just slightly more heart-shaped. I'm going to put in 0, and I'm going to see where this aligns this time. Okay, so it's moving faster this time. So I have sort of a spiral shape, and here it is. It's at 19, 20, you know, it's somewhere in between there. So maybe it's 19.5. Okay, it aligns pretty well. If I zoom in on this, so pretty much perfectly at 19.5. So I might have thought, you know, 45, that would be halfway between 0 and 90. I might have thought 22.5, which would be half 45 degrees, but no, 19.5. So I just thought that's sort of a weird place for that to align. Continue onward. I notice it's starting to align again. So let's look at this one. So that looks like it's about 75, but it's not there. Okay. Oh, it aligns at 90 degrees. Okay, well that makes sense. Now I go the other way. Okay, it's coming back. It's almost aligned. Okay, there it is at, no, 61, 61.5. Oops. 160.5, which is 180 minus 19.5. Okay, so this 19.5, this is the number, right? And so then you can keep going around, and now it's going to go down and do sort of the same thing in the opposite direction, but it'll be offset from 270 or 180, I guess. Like if I go back to this, let's see what that one is. Yeah, 199.5, which is 180 plus 19.5, and then it goes up to this other one. So that was sort of strange that it had, you know, you can go up to 270, it'll be aligned again, and it makes that sort of weird squiggly spiral shape. All right, put it back to 0. So, but in between 0 and 90, I've got one value. So when B is 2, when B is 1, it aligns at just 0 and 90. When B is 2, I have 1 point in between 0 and 90 where it aligns. Okay, when it's 3, okay, let's see what happens. So when it's 3, I'm going up to 90. So I'm going to start here. Ooh, it's moving fast this time. Okay, there it was, 12.5. I'm going to zoom in on that. Yeah, it looks like 12.5. Okay, so now it's less than 19.5. Okay, that's no surprise really. And I guess I got another one in here. I got another spiral here. Here's 28, 27, 7.5. That's not quite aligned. So I could tweak this and try to get it just right, which I did. And this is what I found. Up here, I was trying to understand this because I thought, well, gee, it'd be nice if I could put it into a formula so I didn't have to figure out this weird factor for this number. And so I found out that, well, if my b value is 1, then it aligns only at 0 and 90. If my b value is 2, it aligns at 0, 19.5, and 90. If my b value is 3, it's at 0, 12.5, 27.7, and 90. So let's try that one, see if I got that right. 27.7. Yeah, seems to align that curve really well at that point. Okay, so I went on. So then it's like, okay, well, each time I increase this b value by 1, this value adds another sort of point of alignment between 0 and 90, like that. And so this one has 1, 2, 3, 4. This one has 5, so it's n minus 1 alignments between 0 and 90. Okay, but then I noticed, look at this, here's 19.5. So at 2, this 19.5 repeats, and every even number of b, it's repeating. So I mean, maybe there's probably somebody out there. There's probably somebody out there who's going to look at this and say, "Oh, yeah, that's obvious. It's this." So hopefully you are out there watching this video and you can tell me what's going on with this. But first thing I noticed, oh yeah, look at that. It's repeating. And so I just started coloring them, and I made these sort of red, these sort of orange, those associated with 4 kind of yellow, those associated with 5 kind of green, those associated with 6 kind of blue. The next thing I notice is, okay, did any of these others repeat? So I noticed over here when b is 3, that I get a value of 12.5, and then over here at 6 it's 12.5, and then over here at 9 I get 12.5. So my b value is repeating every every 3 places, okay? And then if I look at this one, 5, it's 7.38, and then 7.38 over here. Oh, I see the pattern now. I'm happy because I can see, okay, these 5 values, they start showing up over here at 10. And the 6 values should show up over here at 12, which I think I haven't actually tried those yet. So I haven't mapped out 12 yet. But somewhere over here, I should have these 6 values. And then I get to 7. Nothing matches. Oh yeah, because 7 is prime. I get to 11. Nothing matches. Oh yeah, 11 is prime. So on these prime numbers, none of the alignments are related to any of the previous ones. However, if I look at this 27.7, it lines perfectly at 27.7 when b is 3. And so then I looked up, well, it should align that way at 6. But it doesn't. It has, it gets this one sort of over, I get 32.7 from 4. I get 19.5, but I don't get the 27.7 for some reason. But that one comes back again up at 9. Okay, so I'm trying to figure out the pattern to this, and I can see that this number is going to asymptotically approach 90, this one next to it. So it's going to get closer to 90. So how fast does it approach 90? Well, not too fast. I put in 50, then it is the first value you get is 60.7. So if you look at this one, we're only 2 values between 0 and 90. This is 19.5, so it's not that close to 90. It's sort of, and it's less than 45, and it's less than 22.5. So it's sort of on the lower side of the range between 0 and 90. And you'll see that this number gradually goes down, and it's approaching 0 asymptotically. I didn't do that one, but it's probably getting closer and closer to 0, while this one's getting closer and closer to 90. But I started looking at this one, seeing how close it would get to 90 after if B is 50, it's at 60.7. If B is 100, it's at 65.5. B is 250, 70.5. B is 500, it's 74. When B is 1,000, it's only up to 76. If I make B 10,000, it's only up to 82.3. So it's slowly approaching 90, but it's pretty slow at getting there. And this one is getting smaller and smaller. I didn't mess around with that. Although I think when it was 16, there is a value at 2.3. Anyway, I tried making a graph of this to see if I could, maybe it's, linear or quadratic or sinusoidal or cubic or exponential or some other function. And I couldn't find a graph that would match this. In fact, some of the things I noticed, it's going up by a certain amount, but then it doesn't seem to follow that pattern anymore. So you'll think, oh, the difference between these two is a certain amount, but then all of a sudden it messes, the pattern doesn't fit anymore. So I don't understand it. Just sort of a bizarre thing. And so I did make a chart, so I knew which values to put in for different values of G, or for G, in order to get G to align. But that's all I can do is make a chart. I can't come up with a formula to get that to align. So there's my long rant on numbers. Meantime, I know it aligns at 90, so you can always do it that way. And it would also align at other factors of that. So I'm going to go back, set this back to 0, and let's look at the rest of it. So if I just do this one, it will eventually turn into a heart. It looks pretty good at, somewhere around 30. Even by 16, it's slightly heart-shaped, but not quite a nice Valentine shape. Got to bump this one up to 2. Now it comes up to a nice Valentine shape. And now if I wanted to make this offset, I don't have this one written down, so you'd have to find, there's some number between 1 and 2 that allows this to line up perfectly. And you'd have to figure that out, like start with 1.5, that's too much. So go back to 1.2. Okay, that's too much. 1 point, maybe it's okay, so it's pretty close to that, but it's a little more than that. I mean, that's not too bad right there. Need to go a little more. Let's try 1.12. Okay, 1.15. Okay, so that's pretty good for my alignment for that one. But you sort of have to line these, and actually if I look up here, I think it's just a little bit off, but I don't know, it's lined that way. You also notice that weird black line in the middle has now gone away, so that thing can show up at weird times, and I believe it's related to that arctangent function. You can mess around with fading these in and out and trying different colors, but I haven't messed around with that too much. I can subtract off the color too, or get them to blur, overlap. I guess this is the F is the overlap, and then these are the two edges. Put tighten up these edges. You can, let's see, I need to make this a little bit, and then we'll just put this one down. Well, if I go up to 90, I know it'll align, but now it's got so many loops in it that it's really hard to see what's going on. And so then if I do, let's try 180. So now I've turned the Valentine upside down, and then 270, it'll have all those lines again. and then 360 it's back to where we started at 0. So that's sort of phase of that. And this one controls the scale, so you could zoom in, and I think that's it. Oh, this one, yeah, so this one sort of distorts it. So let's go, I'm going to zoom out a little bit, and if I, let's see, I think if I distort this a lot, oh yeah, it'll start doing weird stuff like that. But I want to bring this one, oops, down. Let me see. I think this, if you bring this one way up, oh yeah. So if you bring this one way up, this one starts forming these weird Valentine shapes like that. So you can get, I'm going to zoom out just a little bit. Yeah, you can start to get some strange looking shapes. I'm going to create a preset for that one. Let's call it, oops, square heart, like that. So this one is all the way up to 80, and then this one is only 1. And then if I, now when I change that, it changes quite a bit. All right, yeah, just a weird sort of oddity. I was going to wait and do this on Valentine's Day, but that's a long ways off, so I guess I'll do it now. Maybe I'll come back to it then. Maybe by then I'll understand what's going on with the numbers. All right, thanks for watching. Let me know if you have any comments or questions.